Hi, this is Tim. In this lesson, we're going to continue working with Industrial Concepts Motion Control Trainer, and we're going to be integrating the encoder of it to the high-speed counter of our PLC trainer. I'll put links to both of these in the description. In our previous video, we went through the basics of connecting this and showed a little bit about how pulse and direction works. So I'm just going to do a quick review of the connections we need to make on this. As first, on our stepper motor, we're going to connect wires to the A minus, the A plus, the B minus, and the B plus. And you can just color code connect them just like the connectors are. And they're all going to go to the stepper driver right here. So the green one is the A minus, the blue one is the B minus, the red one is A plus, and the yellow one is B plus. And then we're going to connect some commons. We're going to connect a common from the ground of our stepper driver to the PLS minus, and then from the PLS minus to the DIR minus, and then from the DIR minus to the ENA minus, and then connect a wire from the ENA minus, and just leave it loose right now because we're actually going to connect this to our PLC trainer power this time. And now let's do our plus 24 volts. So we're going to need a wire from the V plus of our stepper driver to COM A of our dial switch, then from COM A of our dial switch to COM B of our dial switch, then from COM B of our dial switch to the red part of our right limit switch, then from the right red terminal limit switch to the left red terminal of the limit switch. Then finally, let's take a wire from the V plus of the stepper driver, and we're going to leave it loose because we're going to connect it to our PLC trainer. Then let's hook up a wire from the black terminal of the right limit switch to the black terminal of the left limit switch. And then we'll take a wire from the black terminal of the left limit switch, and it's going to go to the enable. And what this will do is it'll apply 24 volts to the enable whenever either of these switches are pressed. And the way the enable works on this is you put 24 volt on it to disable the drive. And finally, we're going to take a wire from terminal 1 of our A position of our dial switch to the pulse plus, and from the terminal 1 of our B dial switch to the direction plus. That gets us pretty much where we were in the previous video, with the exception that we did not connect the plus and minus 24 volt to this power supply because we're going to connect it to our PLC trainer. Now let's get power to our encoder, and we're going to be using the A and B signals coming off of it. So I'm going to connect wires to the V plus, the ground. I'm going to connect our yellow wire to the A and a green wire to the B. Now the A and the B, just set it up there with those power wires because we're going to connect those to the Micro850 PLC. And then the plus, we're going to connect to anywhere that we have plus jumpered throughout here. So I'm just going to connect it to the top of COM A of our dial switch. And then our ground, I'm going to connect here at ENA minus. So that'll get us 24 volt to our encoder, and we're getting an A and B signal off of it. Now let's connect the plus and minus to our power supply. So the red is going to go to the plus of our power supply, and that is any of the left group of terminals. And the black is going to the minus, which is any of the right set of terminals. And then we're going to be using high-speed counter 0 in this, and it's going to use inputs 0 and 1. So A is going to go to input 0, and B is going to go to 1. So A was our yellow wire, so I'm going to connect A to input 0. Then we're going to connect B to input 1. We've done several videos on connected encoders and configuring high-speed counters for the Micro850. Just a quick review is where typically we would be using syncing inputs. In the case of most encoders, they're going to be open collectors. And open collectors are a syncing type output, so you have to match them with the sourcing type input wiring. So whereas normally we'd have COM0 going to the minus and we're sending power to each of our inputs, in this case we're going to have to feed 24 volt to our COM0. And then that plus 24 is going to go out to our A signal and our B signal, and it's going to sync it back to our common as it's sending pulses. So I'm going to connect a wire to COM0. And actually, while we're here, let's make sure we understand COM0 is actually used for inputs 0 through 7. So all of these inputs are now going to be configured as sourcing inputs. So we're going to connect that wire that I connected to COM0 to our plus 24 volt, which is our left set of terminals. Now that we have that wired, let's power up our Micro820 so that we can test our encoder. One thing that can be a bit confusing is people want to know whether should you have a 1 or a 0 or what should you have there. Well, you may have 0 on, you may have 1 on, you may have both on, or you may have none on, just depending on the particular encoder position. But if you just grab the shaft and just move it a little bit, it'll wiggle and you should see these lights flicker on and off. And as long as you're seeing input 0 and 1 flickering on and off, then you're good to go. Now we're going to need to write some program in Connected Components Workbench to configure our high-speed counter. Let's create a new program in Connected Components Workbench, and I'm just going to call this our stepper HSC. And then we're going to go to controllers, and this is a Micro850, and we have a 2080 LC50 24QBB. We're going to select it and add to project. And then right away, let's go ahead and set up our Ethernet IP configuration. So we're going to configure IP address and settings, and it's 192.168.110, the subnet at 255.255.255.0. And then right click the main task, add ladder diagram. And let's open it up. And then we have our tabs across here, and if we go over a little bit, we're going to see the HSC tab. And we're going to bring down the HSC configure and run instruction. And if you mouse over these, it tells you exactly the data type you need. So the HSC command is an unsigned single integer. So I'm going to double click here. I'm going to go to a global variable, and let's call this our encoder CMD. So that's going to be an unsigned single integer, or USINT. And then the next one is an HSC app data type. So we'll double click here, and we'll call this our encoder app, and that will be an HSC app. Then we have an HSC STS, so we'll call this our encoder STS, and that will be an HSC STS. And then we have PLS data, which is data type of PLS. And notice that 1.1 in the brackets. So we're going to call this our encoder PLS data. And the data type is PLS. But now this dimensions what we need to put in. It's going to be 1.1. We'll select that. And then we have STS, and actually I should have named this one better, because really that's status. This is status info. So let's double click on this one, and let's change this one. Let's make this one encoder STS info. That kind of matches better with what we have there. And then this one right here, which is a data type of unsigned integer, is going to be our status. So we'll go here and put encoder STS, and that will be an unsigned integer, or UINT. This works for our basic setup of this, but we're also going to need to do some math because this is going to come in impulses, and we want it in some type of measurable value. So, for example, this encoder, there's 720 pulses per revolution. So we could at least get it into revolutions. But even then, there's a certain distance per revolution that we're moving. So we can do some math and we can get this into a measurable distance in here. And here's one of the situations that really structured text works better, because really we can just write out an equation for everything we figure out. Whereas in the ladder, we're going to have to, go to, well, let's just go to our math tab and see what we have. Is we can go to our math and we have subtract, multiply, divide, add, absolute, all those fun things. And even then there's an advanced math tab. Where is the advanced math tab? Right here. And we can do derivatives and all these fun things, but you have to do them as an individual instruction. And a lot of people ask, where is the compute in Connected Components Workbench? Well, it has structured text. And really, when you think about it, a compute statement in ladder is a small structured text subroutine. So we're going to right click here, add, and we're going to add a structured text program. And we're going to actually move our high-speed counter into that structured text. I think it's a little easier, especially starting out, to set up this high-speed counter in ladder or function block, mainly because we can mouse over it here and get our data types and figure all these things out. Also, I may not have stressed enough, but all of these were created as global variables. So if we double-click right here and we look here, these are on our global variable tab. Make sure they're not on that local variable tab. So now what I'm going to do is I'm going to open up our structured text program, and we're going to start typing HSC, and you're going to see the high-speed counter start to come up, but it's not real clear what exactly we're supposed to do now. And that's why I didn't want to start over here. But if we go and we highlight the high-speed counter in our ladder diagram and then hit F1, then it's going to bring up the help file for the high-speed counter, and that includes the high-speed counter in a function block and in ladder and finally in structured text. And this is going to give us the structure that we need, and we've already created these data types now. So in this case, well, one, we have an enable, and I did forget to create the enable, so we'll have to create that one. That's going to be Boolean. Then we're going to have HC, HAD, HSI, and PD, and you notice they are in order right there. So we're going to take the same thing that we created over here, encoder command, encoder app, encoder status info, encoder pulse data, and we're going to lay them out in the same way. So we're going to go to our structured text program, and we already typed HSC. Actually, let's just start over, and let's type HS, and you're going to see all the options start coming up, and most of these are the same commands you're already familiar with, but we want that HSC right there. And at that point, you're kind of like, well, what am I supposed to do? If you hit parentheses, then it'll say create new instance. So we're going to create a new instance of it. And there we are, HSC. And we can name it here. We already have an HSC1 up here in Prog, and I don't think HSC1 is necessarily a good name for this. So let's call this our encoder HSC. And click OK. And now we'll open parentheses, and here it kind of tells you what you're going to need. Boolean, enable, command, data. So this is all the stuff we already created, except for the enable tag. I did forget it. So let's go to our controller variables up here. We could have done it from there, but let's just go down here and type encoder enable, and that will be a Boolean data type. All right, now let's go back to our structured text program. And so that kind of gives us our layout here. So start typing encoder, and you're going to see all your options come up. So we're going to select the enable, comma, and there it goes again. So this time we're looking for the command. So encoder, and find the command, comma, and then we have the app data. So encoder, and then we want the app, comma, then we want the status. Remember, that's the one I renamed later status info. So encoder, and then status info, and then comma, and then we have the pulse data. So encoder, and we want the pulse data. And then we're going to hit the close parentheses, and then a semicolon. So this command right here is exactly the same as this command right here. Now notice in the structured text version, we never use this encoder status or this status right here. We used all the inputs on it. And when we had hit the F1 key, you see there's a second line to this high-speed counter. We have the status, or in our case, encoder STS equals, and then it'll be encoder HSC dot STS colon. So let's go back over here, and we're going to have a second line that will be encoder status, or STS, colon equals encoder HSC dot STS. And then we need that semicolon. Now, if you recall from my previous high-speed counter video about the Micro850, there were some variables that we had to set to do this. And right here they are. And actually, this is one thing I like about using the structured text, is this is going to lay out a lot nicer. We used initial values to set all of these in that video. And so in that case, it's not really clear where they came from. And in this video, we're going to spell out these things right here. So our high-speed command, we're going to set to 1. The pulse enable, we're going to set to false. The high-speed count app D, we're going to set to 0. And we're going to do this right in our structured text program. So actually, we're going to declare all this before we execute this high-speed counter right here. So we're going to say that our encoder command colon equals 1 semicolon. Then we're going to say that our encoder app dot PLS enable colon equals false. The semicolon. Then our encoder app dot HSID colon equals 0. And this HSID, actually, this is where you specify which input you're using. Now the HSCID 0, that is input 0 and 1. And if we go back to our help over here, I don't remember whether it spells it out. Yeah, okay, right now we're on the high-speed counter, the help for it. If you scroll to the bottom, there's the HSC app data type. And this gives you info about that. And at first it looks like they're not really telling you anything about the HSC ID. But if you'll scroll on down, then it goes in the definition of it. And the bits of the HSID, that's going to determine where you're actually using. So you could be using the embedded, which is what we're using, but there's also expansion modules that you could have to the right of it. And also you have the plugin modules that you could be using. And in our case, we're using the embedded for the module type, and we're using the embedded for the slot ID. And again, we're using the embedded for where exactly it is. So ours is 0. And also while we're here, right below it is going to be the mode. And we're going to be using mode 8, which means we're going to be using inputs A and B, and we're going to be counting in quadriger mode. We'll see in a second what that means. But okay, so actually right after that, and again, right here is what we're actually following. Is I've gone false on that. I just put the ID of 0 in. Now we're going to put the HSC mode to 8 and encoder app dot HSC mode colon equal 8 semicolon. And then we need to set these ranges. And this can kind of drive you crazy if you've never used this before, is really your counter won't count because default, these high and lows are set to 0. So we're just going to set them to the largest number possible on both the high end and the low end so that we don't have to worry about those. So it's going to be encoder app dot HP setting colon equals, and we're going to do one less than the maximum number of a 32-bit integer. So that is going to be 2147483 646 semicolon, and then we want the encoder app dot LP setting to colon equal, this one will be minus 2147483 647. Then our encoder app dot OF setting is going to be that actual high number. So colon equals, and it's actually going to be this number right here plus 1. So it's going to be 2147483 647 colon. And then the encoder app dot UF setting colon equals, and we can just copy that number and paste it here and add 1 to it. So it'll be 2147483 648. Oops, that should be negative. And also I forgot, well, there's the semicolon there, and I forgot a semicolon up here on the LF. So that should get us there. Now one thing is we still have this high-speed counter here. We need to just delete it. And let's go ahead and download this program and see what it does. Uh-oh, well, we're not going to download our program because I have build errors. So I should have done a build of it to make sure what we have first, but okay, expected. All right, and I'm always bad about this. Apparently I missed some semicolons or something. Speed counter app D. Well, that looks right. Well, let me hit the build button again. All right, expected, and here's where sometimes you've got to figure out which one's on the top, but all these show on line 4. So expected before this new statement, Encoder app, high-speed mode. That looks right. Okay, and here's where the build doesn't always work great. Oops, did I close that build? Let's see, hit the errors again. Is I have 3 errors, and they're all pointing to line 4. But my error is not in line 4. My error is in line 3. See, I forgot the semicolon right here in line 3. So actually, I have 3 errors right now, and they all show in line 4. But yeah, now that I have that semicolon there, we'll hit the Verify Program button. And yes, build succeeded. Also just realized I forgot one other thing is we added this enable right here, this encoder enable. This wasn't actually necessary in the latter version of it. And we need to add it. So right below there, we're gonna put encoder, and we're gonna find that enable, colon equals true. And then we'll put a semicolon after that. And also, absolutely the most left out thing out of this, I mean, the thing that I get the most people saying, hey, my high-speed counter doesn't work like yours, is we need to lower our input filters. And I really feel that there's some way that Rockwell could warn you about this. If you have a high-speed counter configured, it could do something to let you know that, hey, your input filters are set too high. Most PLCs actually have some type of filtering on their inputs to help them make them more noise immune. So there'll be a little ripple in the power. Well, you don't want to be detecting that all the time. So you'll put a filtering in there so that an input has to be on for a certain amount of time or off for a certain amount of time before it actually detects it in the PLC. The issue is those ripples look very close to an encoder input. So what we need to do is we need to go to our controller properties, which we can get to by double-clicking the controller in the top of the left pane. And then we need to find our embedded I/O. And right here, we have our input filters, and we've connected our encoder to inputs 0 and 1. And we just want to take those and we're just going to put them on the lowest setting. And if you're curious about those encoder settings and where those filters need to be, we do have a video where we played with lowering those filters down and figured out exactly where they could be and still work. So I'll put a link to that in the description. Also, there's a video on how encoders work, and that would probably be a good one. But this should be enough to get us started. So we're going to go ahead and download our program. And if you need any help downloading your program or configuring your drivers, or if any of the more basic steps you felt I went too fast through, check the description. We have a whole lesson series on the Micro800 PLCs and Connected Components Workbench. Okay, we're running. And now let's open up our controller variables and let's find the Encoder App Variable. And let's open it up. And if we scroll down just a little bit, we're going to see our accumulated value. Now, if I have this right, if I just grab this shaft and turn slightly, yep, okay, we got a little wiggle out of it. And a couple things here is if you have yours wired correctly, then if you grab your screw and try to turn it, it's not going to turn. But if you will press one of the limit switches, that's going to disable our stepper driver. And that's going to allow you to turn it. So now, that little bit of wiggle I just did, that was 230 counts. And if we turn it some more, then yeah, we're definitely counting. If we turn it the other direction, it's counting back down. And if you're curious about how it counts up and counts down, we do have a video that explains that. But all right, let's just bring it close to 0. We're not even going to worry about it being perfect. But okay, that is close enough. So if I turn this a full turn, let's see how many counts we get. So all right, I got a good reference spot there. I'm going to spin this a full turn. Okay, and we got roughly 2,800 pulses. Now at first that may leave you scratching your head, because if we look at our encoder, it says 720 pulses per revolution. If you recall from our encoder video, we have an A signal and a B signal, and they're offset. And that actually creates 4 unique points as you watch the rise and fall of them. So that quadruples or makes a quadrature amount of accuracy. So that's what it meant when we put it into quadrature mode. So we're going to have 720 times 4, or 2,880 pulses per revolution. Okay, so now that we know that, we can turn this accumulated value here into revolutions. So let's go offline, and then let's add another line to our structured text program, and let's type encoder revs. And that is going to equal, which don't forget that when you're saying something is equal to something, you actually hit colon equal the encoder app dot, and we want that accumulator, divided by 2,880. So let's make sure we're right on that. If we go to our calculator, then 720 times 4 for that quadrature is going to be 2,880 pulses. So here's where that 2,880 number is coming from. Now that we're actually going to have a little bit of an issue here. We need to go ahead and resolve it pretty quickly. Let's say we had, I don't know, I'm just arbitrarily going to say 51 pulses. Well, that means 51 divided by 2,880 is going to equal a decimal number. So we know this result here needs to be in a decimal format. So I'm going to click on our encoder revs, and we're going to click variable selector. Actually, I should have created that earlier, but we're going to go to global variables, and we're going to create a variable called encoder revs. And we know this needs to be a decimal type, which is going to be a real data type. So we're going to select it. And now let's hit the build button on this. And okay, we're going to get an error here. Equals must precede a real expression. So what this is saying is if I'm using a real number here, then this needs to be a real number and this needs to be a real number. Now, real number, remember, has a decimal. Well, if you have a static number such as we have with this 2,880, a real number is 2,880.0. So that fixes that one. But now let's hit the build button again just to see that that doesn't fix our problem. All right, now, invalid right operand, expecting a dent or a double integer, and then again we're getting that same real must proceed. And the issue is this accumulator is a double integer. Let's go and make sure we see that. So if we open up our controller variables and we scroll down to our Encoder app and we look at our accumulated value, our data type is a dent. And so over here it expects this to be a dent and this to be a dent. So all these have to match in some way. So we're going to use an instruction called the any2 instruction to fix this. So in front of encoder, we want to hit a space there. And then that way you're typing kind of in the middle of nowhere. Start typing any. And you're going to see all of the any instructions come up. And we're going to be looking for this any2 real instruction. And what this is going to do is take anything and turn it into a real. And we're going to put a parentheses. And then we're going to have our encoder accumulator in there. And we're going to put a close parentheses there. So now let's hit our build button. Uh-oh. I made a mistake. What did I do wrong? Oh, whoops. Okay, well, and I forgot my semicolon on the end. So yeah, and you'll find that throughout my structured text videos, I forget these all the time. So there's my semicolon. And we're going to hit the build button again. And there you go. Now it says build succeeded. So let's download this. And now let's open up our controller variables. And first let's scroll down and find that encoder app that we were looking at before. And we're going to see our accumulated value. And right now it's at 0. And then probably you can scroll down just enough so that we can also see our encoder revs, which is also set to 0 right now. So I'm going to hit one of our limit switches. It's going to disable my servo. And now I'm going to turn it approximately 1 turn. All right, and so we have 2800. Ooh, and we bounced right at the 2880. I can't believe I managed that. And we have exactly 1 rev. So now we have taken our raw encoder counts here, and we know that we're moving 1 revolution. And that helps us a lot, but even then, I would rarely want to be scaled in revs for a linear application. We want to know where we're moving at this way. So I know that each turn of this screw is 4 millimeters. And just a little bit about how you can figure that out is I have the 1-inch mark at the very top of that screw pitch there. And if you look at the next mark, it's at 5/32. Now, if I thought to bring a metric tape measure from the shop, then it would show exactly 4 millimeters. So let's go back offline, and then let's add a line to our structured text program. And we need, well, one, we need a variable here. So let's just right-click, variable selector, and go to our global variables, and we're going to create a new one called encoder for encoder millimeters. Actually, let's spell that out because we use way too many acronyms and abbreviations. Let's make this millimeters, and that will be a real. So encoder millimeters colon equals, and this will be encoder revs, which is what we just created above, divided by 4.0. And remember that 0.0 is important for the exact same reasons it was above. And then we'll hit the colon. And then actually while we're at it, maybe you want to run it in inches. So let's create another line and right click, variable selector, and we're going to go to our global variables and let's have encoder inches. And this will also be a real tag. And we could make it this millimeters divided by 25.4, but let's make it based off of this revs, because if you're not using millimeters, you probably wouldn't ever create this particular variable. So colon equals encoder revs divided by parentheses 4.0, because in the end this is a 4 millimeter pitch screw, divided by 25.4, and that's going to put it into inches, close parentheses, colon. So let's go ahead and download this program. Then let's open up our controller tags. and scroll down. And again, let's open up our app data. And we want to find our accumulated value. And we hope that we can see our accumulated value, our millimeters, and our inches at the same time. So one revolution of our accumulated value should be 2,880 pulses. It should also be 4 millimeters. And finally, it should be whatever 5/30 seconds is in decimal. Let me just hit my calculator. And to figure out 5/30 seconds in decimals, we're going to do 5 divided by 32. It should be roughly 0.156. So I am going to hit one of my limit switches so that I can disable the stepper drive. And then I'm going to rotate it approximately 1 revolution. And we're grossly off because I made a mistake in my calculation here. If we go back and look at our program, then I divided by 4, and I divided by this number, but 1 revolution times 4 should be millimeters, and times this value should be our inches. So that's my fault there. So let's go offline and fix that. And all we have to do to fix it is right here where we have that divide, we just want to put a multiply, and same right here. Now make sure you get the right one, and the inches one is it's encoder revs times, and then we still want this parentheses 4 divided by 25.4. Now let's download that. Now let's open up our controller variables and go back down and open up our Encoder app. Let's get it where we can see our accumulated value and our millimeters. And this time, when I rotate this screw 360 degrees, all right, we're showing, oh, well, man, I managed to do that again. 2,880 pulses, which is exactly 1 revolution of that encoder, is 4 millimeters. And if we go back to our calculator, and yeah, that's about right, 1.56, 1.57, that's really close. So there you have it. We have configured our high-speed counter, and we have also converted it to millimeters and to inches. In our next lesson, we're going to start configuring our motion axis over here and start doing some basic positioning. So I hope this video has been helpful. Please hit that like button and subscribe to our channel. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!